Welcome to part 6 of the EV conversion of my VW bus. In this video, we will be building this high voltage contactor box and all the high voltage cabling, so stay tuned and see how I did it. Alright, here is the contactor box layout. This is all the parts I'm going to try to cram into one little box here. I had an 8x8x4 box, but it had a lot of cutouts and holes in it, so I thought I'd buy a brand new one and start fresh. So there's that. Then we have a couple Curtis Albright contactors. These I showed in my part 3 video. I thought they were different contactors, but no, they're both just the Albright SW200 contactor, but just with two different brackets. One which holds it up vertically and a couple brackets that hold it up horizontally. I just flipped this one around and I'll show you why later. This is kind of a large contactor, much larger than the Gigavac, but I'll show you how we can use both of these orientations to make different arrangements depending on your box size here. But these are a 400 amp uninterrupted continuous duty, and I think at 600 amps they're about 50% duty cycle, so it's a pretty stout contactor here. Next we have a 6-pin harness. This is going to go from our DC to command center, our 12 volt command center, this one, and then this is a flange that's going to be mounted on the box, and so we can plug into it, and it's all waterproof. To find these, I actually got these from an eBay seller who makes these in multiple different pins. This happens to be a 6-pin, but he makes them in all different size pins from 2 on up, and also puts wires on them, pre-solders all the pins and puts them together with these 6-inch wires, which will help me in saving me time in soldering. But these are Deutsch connectors, so I'll provide a link in the description for one of these, but you can also search for these on eBay and then also include the keyword flange connector, and that'll be the flange style where you've got this where it can be mounted to a box. Then we've got some various copper bars for transitioning out of our contactor. We've got some standoffs. These are, I bought several of these for my previous project, so I'm just reusing these. They're plastic standoffs with a 3/8 inch stud. Then we've got a fuse holder for the large style, the KTK style fuses. This is a 600 volt fuse for the DC to DC converter. Our main 500 amp bus fuse. And then we've got some different gland nut of varying sizes, from 1 inch down to 3/4 inch. Then we've got, or maybe that's 1/2 inch, I don't know. Then we've got a relay here. This is a power relay. This is rated at 220 volts DC at 20 amps with a 12 volt control. So it's just a simple power relay that we can use for our DC to DC converter. And then we've got a little terminal strip here. And that's pretty much the layout. We're going to try to get everything fit into this little box here. So the biggest item to start with fitment, and of course I'm not one of these people that does all these, knows how to do CAD or working out drawings and digital drawings and all that. I'm just going to do brute force, just trial and error and try to figure out what fits. So I've got these two arrangements for the contactor, which can go either vertically or horizontally. Well, what would work the best? Well, I started with this one, and I think this is the one I had. And I had this kind of twisted copper bar, which allows you to transition out of the stud here and onto a flat kind of plane. If you can see that. And then I've got these standoffs here are very helpful, these little 3/8 inch stud standoffs, because then you can transition and make yourself a custom fuse holder. So for example, I could come out of here, transition that copper bar onto this stud terminal, and then make myself a little fuse block here, and we could go through it like that. So in here and then out here. Problem with that is it takes up quite a bit of room, and so I had to figure out another way to solution that. Well, I mean, if you have a long vertical box, you could do something like this where you take just an L bracket of copper and kind of transition out of that. This doesn't really fit, I need to widen this hole out, but you get the idea. This L bracket could transition it a little bit further away. There was other ways I think you could do, this type of thing where you can go out forward from this. You could go right off. You can't go right off of the side here just because the fuse doesn't really fit, but you might be able to figure out a way to come off top. So if you have a tall box, you can do something like that. What I decided would make the best use of my space is to take this vertical one. And as you can see here, I turned that bracket around. It used to point that way, but that way I can fit it tight up against the wall. But the other thing this allows you to do, even though this takes up more space horizontally, what I found I could do is take these terminal studs and actually put the fuse underneath it. So I think using one of these L brackets, let's see if it'll fit. Oh, it does fit on there. So that fits on there, and then you can basically put your fuse, forget what arrangement I had. I think the fuse went on first, and then this drops onto the fuse, and then that makes probably the tightest setup there. It's all kind of encapsulated in this area, and nothing comes out from it. So I think I'm gonna go with that, so I can basically go into here and out right above it. I'm using a lot of real estate in this box. This is pretty cramped, but I got it all in. Just at a high level, I'll just explain that we've got the three inputs on this side here. We've got our wiring harness from our DC command center here. I still have to make this harness and tie it to the DC terminal strip in the DC command center. That'll just plug right in here. Everything's so far is waterproof, amazingly, so that's also a nice bonus. So that's that flange. Then we've got two gland nuts. I think these are 3/4 inch or something around there, and these will be our inputs. Our positive 2.0 cable will come in from here. This actually comes ultimately from the battery, but from our disconnect switch, and then the negative from our battery comes in here. So the negative is pretty simple. I've got just a single 3/8 inch terminal stud here, and I actually have a lug on here just for display purposes, not connected to a cable. But anyway, cables like that will be coming in. That will lug onto here. The positive will lug onto there. The negative's just going to simply lug onto there, and then there'll be another one coming out through this bottom hole that lugs onto there as well. And so it's really just kind of going in and right back out. But then I can hang my other negative high voltage cables off of that stud as well. Positive's a little more intricate here, so we come into we lug it onto right here. The input goes through the fuse, and you can see our DC converter and our charger wiring is on that end of the positive. Then that comes up to this copper plate and hits the contactor. And then when the contactor closes, it closes to here. Then we'll lug a cable much like this, just for display purposes here. That will come off this top gland nut here. So that'll lug right to the contactor side and out of this top gland nut here. That's pretty much all the high voltage stuff here. Obviously we have the high voltage cabling being coupled together to go out of these two things to go to our motor controller, but also to the input of our DC to DC converter, the high voltage input, the positive and negative, and then these two are 8-gauge cables that will be going to our charger. I didn't have different colors, so I'm just going to use the same wire for both positive and negative, and then I'll add an Anderson connect on there, and that'll connect to the existing charger output, and we've got the charger and the main controller harness here, and everything coming out the bottom. We are back in the shop. A little over a week's gone by, and I'm delayed in this video because COVID ran through our household, and I got pretty sick, so that was provided a bit of a detour and a delay. But back in the shop, as you notice, I've got all the high voltage cables going in and out of it. I decided just to go ahead and just get it all done. Everything from the battery to the controller is now, the 2/0 gauge or 2/0 gauge cables are all sized and created and relugged to the size they need to be. And I was just going to give you a little bit of a
a description of what I do for the cable, for the 2.0 cables, for anybody else who's new to EV conversion. There's a couple different cables that you might encounter. And again, this is 2/0 is not 2 gauge. It's below 0 gauge. So there's one, you have 2 gauge, and then you have 1 gauge, and you have 0, and then you have 1/0, 2/0, 4/0, and it starts going up that way, which increases the size of it. So 2/0 is the cables that I'm using for just about everything, so that it can handle that high amperage that I need at 144 volts. Notice I've got a couple different kinds here. I've got this black cable. This is a welding cable. It's got really good quality copper conductor, but it's got pretty thick stranded conductors, so it's pretty stiff stuff and doesn't bend really easy. It's cheaper, by the way, than say this stuff, which I think is TriStar. This orange cable is much more, it has a much more finer strand conductor, so it's a little bit better quality. But this stuff, the black stuff, it still works really well. It's just stiffer, like I said, and so I'm trying to use that in everywhere I can because it is the cheaper stuff, and everywhere I don't really need it to be flexible because it's just going to be kind of static. It's going to stay where it stay put. So basically all the cables coming in and out of it, it's going to stay put. Now I do have one orange cable going in that I already had lugged with an Anderson disconnect side of it, which is this big old, this is going to be where I mount that side of the positive, which is going to go into the main disconnect. That's going to go out into here, this black one, and then into the controller for the positive. We already talked about that. And then the negative is going to go to the other side of this Anderson disconnect, and those are going to go through the wall, and I've already drilled for that, and that's what's going to be my main battery, positive and negative. And then I'll have another one of these that plugs in the other side. That's going to be the positive. Actually, this is probably going to be it. This was on my old car, but I'll probably have to resize this too. But here's the other side of the Anderson disconnect that's going to go to the battery side. So I'm going to have, at the end of this, everything done as far as high voltage cabling from the battery all the way to the controller, and then I just need to do those 2 positive and negative controller cables going to the motor, and then any interconnects in the batteries, and that's pretty much it. So at the end of this video, I got more than I thought done, because I'm actually going to be pretty much almost done with all high voltage cabling. So what I wanted to talk about is how, what the type of cables I'm using, and how do I crimp and customize them, right? So once I determine the angle, so this one has to be at a right angle, and then coming out, it needs to go to here. So I try to get all that figured out, the angles, because you can't just like put them on both flat, like in this situation where this one's going kind of up 90 degrees, and this one's kind of be flat to that 90 degrees. You see the difference there? And you can't really twist these cables very well. I mean, they're just very large and stiff. So you want to get the angle right, and then you want to get the size right, obviously. How do you cut this thick stuff? Well, I've got a pair of bolt cutters. There's smaller heavy gauge cable cutters that you can buy that not this big, but a pair of bolt cutters will work just fine. So you can get if you get a cheap pair at Harbor Freight, that is more than enough to cut these wires to the length you need. And notice I have tons of wire, because I had before in an EV, I had cables running from front to back of the car. So I have a lot of this stuff that I can cut up into any length I need. The other thing then you'll need is obviously your lugs, right? So I got these nickel plated 2/0 gauge lugs at the right size, and I drilled this out because my controller needs 1/2 inch, but everything else is pretty much 3/8. So for the most part, I got 3/8. Well, I bought 3/8 inch lugs, and anywhere I needed it widened a little bit. Maybe it's not a 1/2 inch, but maybe, I don't know, it's a 7/16 or something. It's just a larger hole for the controller. So I just use a step bit to widen those out. I would cut them, like I said, cut them to size with this once I figured out what it is. And then to put the lugs on, I'm using this tool here. Now, I borrowed this tool from my friend. It's called a hex crimp, and it can do all all gauge sizes from 4/0 all the way up to 8 gauge. And what it is you have these dies in here, and you can, I'm not sure, haven't tried doing it yet, but I think you push this in, and there's dies that you can twist and match up to get the gauge you want. Right now it's on the 2/0 gauge, and so I would basically put the lug in there and use these giant crimpers to, crimp around the lug, and you can kind of see the indentations it makes when you do that. I'm just going to show you a video as I'm talking about the process. So like I said, cutting the cables, and then what I would do is I would put the lug up near it and then strip the cable using just a knife, and you just cut all the way around it and then cut in and then just peel back, and you want to get it to where you have about 3/4 to an inch of exposed conductor on the cable. Then once you do that, you kind of, like I said, you want to fit the lugs in and make sure you know how you want the lug oriented. Even before that, if you're doing stuff like this where I've got these gland nuts, they will have to go on first because these gland nuts cannot go past these. So make sure you get your gland nuts on as well. And then once you're ready, what I like to do is I like to put the lug into a vise and then heat it up with a torch, and in this case I'm just using a normal plumbing propane torch, and then I dip solder in. Now it's not plumbing solder, it is electrical solder that I'm using, and I'll dip in a pool of that solder in the bottom there, just enough to where once I push the cable in, where it just gets the top tip of the cable dipped into that solder. I heat it up and then I shove the cable into it, and basically it dips into there, just the end of the cable will dip into that solder, and that just will make sure that we have a nice kind of a solder connection at the end. Then once that cools off, I'll pull on it and make sure that it actually did tin and solder that cable into the lug. And then after that, I will open these crimpers up, and then I will crimp the sleeve of the lug, and that will make sure it is well secure. And then finally what I'll do, I think these came with the lugs, some red and black ones, so I'll shrink wrap those on. And the nice thing about these sleeves is the ones, they'll have a glassy finish in the inside, and then I'll actually heat it, silicone that'll heat up and make a nice watertight fitting. So I'll heat that sleeve on, and then it's done. A lot of care has to be taken when you're doing these cables, because if you screw something up, you forget to put your gland nut on, or you orient this the wrong way, you might have to redo it again, and it's a pain. But yeah, just take your time, and it's not rocket science, but as long as you have the right tools and everything. And I should say the right tools. This thing is probably expensive. Like I said, I'm borrowing it from my friend, and I don't know who makes it. It just says hex crimp, but I imagine it's a pretty expensive tool. The other alternative, and I'm not sure if this goes up to 2.0, but I use this for some of my smaller gauges where that's just overkill, or I don't have it because I'm not borrowing it. But something like this is like a hammer crimper. So what you could do is, if you have like I've used this on 2 gauge and up for like battery cables, is once you get the lug on, same technique, you'll put the lug in here, drop this on it, and then take a hammer and whack it real hard on the top, and that will put an indent. With this little jig here, they'll put an indent, and then you flip it over and whack it again, and so you put an indent on a couple of the sides, and that's how you do it with one of these hammer crimpers. Now the next thing to do, well, and I'll also mention, is the other thing I did was, like I said, since I've got all the way done, I've got these gland nuts on each side here. I actually ran out of gland nuts, so I'm just going to use one of these flexible conduit things. It kind of works the same way, where it goes through the hole and we can tighten it in. But what I'm going to do is, if you look at the bay here, I've had to make a couple different changes with this new box. The new box has 4 corners on it, and so I needed a little more room in here, so I moved everything over a little bit, the controller and everything. But notice that there's a couple holes back there. And by the way, there's my new wiring harness the 12-volt wiring harness, so that's all ready to go too. Notice there's a couple holes back there, and those are where my positive and negative cables are going to go through the cargo deck of the bus. So when we look at it from the inside, those holes are right there. All right, well, I saved you the frustration of watching me go back and forth trying to get this thing installed. It's pretty tight when you're trying to get bolts up into there. So that didn't think that through altogether. But the one thing I know about contactor boxes and controllers is you typically don't touch this stuff after you're installed. That's why I chose to put them all the way in the back there, because it's just not something I, at least in my previous EV conversion, I ever had to touch as long as I got it right the first time. But there it is, the box. It's all bolted in, closed up. As you can see, I have the positive and negative cables coming through the cargo deck there that are going to come from the battery. Negative going right into the contactor box. The positive, though, going with some thick conduit into our switch here, then out of the switch, and then around this black cable, and that's our positive into the controller. Now I've got my low voltage wiring harness, that 6-pin harness, plugged into there, you can see, and I have my main controller, motor controller cables. The negative or the positive is what you're seeing on the top, or that was on the front now, and then the negative's underneath that. So those are going to their respective locations on the controller. I have a boot on the main negative, but not on the positive, because that's the motor negative. That cable will come off and go to the motor, and the motor positive is that same lug. So there'll be a second lug on top of that that'll have a boot on it with a red boot on it. So I'm going to wait to do that. I've got both my harnesses for my main controller harness, that 10-pin harness, the throttle cable harness, and the DC converters all hooked up. There's a bunch of stuff under there, but the Anderson connect to the input of the DC to DC converter is back there, and then the output, I had to move that around to the side of the DC command center there, so that's now going up the side rather than up through here, because everything got, kind of scrunched over and pushed over. This is kind of a mess back there. I need to loom and clean that up with some wire ties, but you can see that what's going back behind here is the charger harness, and that's the charging input harness, or output of the charger and input into the pack, and that's going to here. And I'll have to secure that in some way. I don't want just that flopping around. And then again, the rest of those cables just have to get secured. But everything is pretty much hooked up. Let me show you what it looks like on the other side of the cabin. There's the other side. I haven't connected, or I haven't secured that Anderson connector. I'm going to put a bolt through it and kind of secure it to the back of the cargo area. But yeah, that's the main plug-in for my battery. So my battery's going to have the other end of that Anderson disconnect and the main positive and negative to the battery. So we are finished wiring everything from the battery all the way into the controller. So I'm pretty happy about that. One thing I forgot to do for this box, and I'm going to do right now, properly marked now. Now we are actually done with the contactor box. Well, that does it for this part of the VW Bus restoration series. Appreciate you sticking with me, and we'll see you on the next one.